So we're going to start going through this review portfolio today. um, and we're going to go in the order that we did the course, which means we're going to start with algebra and number. So on the second page, the list of all the curricular outcomes are there, as well as some questions. And so these page numbers with these questions I have cut and pasted and put in this booklet. So if you were working ahead, or I'm not sure if we're going to have time to get through this entire booklet or not in the time we have left, but you can always look and see where these questions come from. You can work on them, try them, and you can check your answers in the back of the book if you wanted to. Okay, if you don't anticipate, Lisa, put your phone away, please. If you don't anticipate needing your textbook, you should be returning it to the library, because otherwise they'll be hounding you for that. Get their library or their textbook back. So this first question, again, it comes from page 158 to 159. This is question 9, so that's where it comes from. He needs to replace the edging on a square rug. The rug has an area of 25 square meters. What length of edging does he need? So what we have here is we have, as it says, a square rug. And the area of that rug is 25 square meters. The edging needs to be replaced on the rug. So that is going all the way around the outside. We need to know what the perimeter of this rug is. That's what we need to find. It is a square, so if we know the length of one side, then all four sides are that same length. And we can find out what it is because remember, the area of a square can be found by taking the length of each side and squaring it. So if you take the square root of both sides, on the right, the square root of s squared is just s, and on the left, s, the length of each side of the square, will equal the square root of the area, which in this case is 25 meters squared. The square root of 25 is 5. The square root of meter squared is meters. So that is the length of each edge of this square rug. Each edge is 5 meters long. And so P, the perimeter, will be 4 times 5 meters. The perimeter of that rug is 20 meters. That's how much edging would be required. Okay. Number 10, Serena collected all the garbage she created in 1 year. The volume of the cube it formed was 343 cubic feet. What was the edge length of the cube? So a cube is a box where all three dimensions, the length, the width, and the height, are all the same. So it might look something like this. It's three-dimensional. The length, the width, and the height are all the same. So maybe we might say that they are all L, because for it to be a cube, all those dimensions are the same. And to find the volume, it will be length cube. Normally it's length times width times height. However, in this case, all the three dimensions are the same. So that's how we get volume. And if you wanted to get L by itself, you would take the cube root of both sides. So on the left side, the cube root of L cubed is just L, and that will equal the cube root of V, the volume. The volume is 343 cubic feet, and we would take the cube root of that to get each edge length. So now we're going to go math 4 for the cube root of 343, which is 7. So the cube root of 343 is 7, and the cube root of feet cubed is feet. So that is the edge length of the cube. Each edge is 7 feet long. So we did questions like this, both using the square root of the area to get the length of each side of a square, or the cube root of the volume to get the length of each edge of a cube. We did questions like that back when we started the course. This next question says, a square wrestling mat has an area of 1,444 square feet. Before calculating the side length of the mat, estimate two whole numbers between which the answer falls. Which number do you think is closest? So that's just like guess and check. We're going to skip though to part B, which is to calculate the side length. And again, each side length will be the square root of the area. We saw that above. So in this case, it would be the square root of 1,444 square feet, which we'll use our calculator for. That'll be 38 feet, exactly. So that's the length of each edge of the square mat. All right, then we go into questions involving radicals. These are mixed radicals because they are a mixture of a integer in front, a rational number, and an irrational number. All those radicals are irrational because when you take the square root of each of those numbers, you get a non-repeating, non-terminating decimal. Goes on forever, never repeats. We want to write them as an entire radical. So for the first one, 3 root 11, what you need to do is express the first number as a radical as well by thinking to yourself, the square root of what number equals 3? And the answer to that is 9. The square root of 9 equals 3. So instead of writing 3 root 11, we write root 9 root 11. That is the same value as the original number because the square root of 9 is 3. You also could have got this 9 here by simply squaring the 3. 3 squared is 9. But now because they're both radicals, you can multiply them together and it stays a radical. The answer to that is root 99. That is an entire radical. There's no coefficient. And you can check to make sure that the number that you started with, which is that decimal, is equal to the answer that we got, and they are. So that means that our number, root 99, is correct. It's an entire radical, and it's equal to the number we started with. So do the same thing for part B. 7 root 2, you need to write 7 as a radical. If you square the 7, it's 49. So that'll be root 49 root 2, which in this case will be root 98. There's the answer. And like we did before, you could check on your calculator. 7 root 2 is that decimal. That should be the same decimal for root 98. And it is. So our answer is correct. It's equal to what we started with. And it is an entire radical instead of a mixed radical. Question C for 3 root 5, that would be root 9 root 5. You need to write 3 as a radical. If you square the 3, you'll get 9. The root of 9 is 3. And now you multiply those two numbers together and the number stays a radical. So it's root 45. Question D, 2 root 7 would be root 4 root 7 because the square root of 4 is 2. And because they're both radicals, we can multiply them together. E says 3 root 3. So again, you need to write 3 as a radical. That'll be root 9. When you square 3, you'll get 9. So your answer will be root 27. And for F, when you square 10, you'll get 100. So that's root 100 root 6. That gives us an answer of root 600. Which again, if we check this on our calculator, the original expression is 10 root 6. And that should be equal to root 600. And it is. They have the same value. So that's going from a mixed radical to an entire radical. Part C, we want to go backwards. We start with an entire radical. We want to write it as a mixed radical. So this is where we need to find two numbers that multiply together to get that number under the radical, but one of them must be a perfect square. 4 times 3 is 12, and 4 is a perfect square. The square root of that is 2. So root 12 should be equal to 2 root 3. So like we've been doing, we can check those. Our original number was root 12, which is that decimal. That should be equal to 2 root 3, and it is. So our answer is correct. The only way that you might get one of these wrong is if you don't take the largest perfect square out. And we'll see, I'll show you an example of that, what it looks like. But question B, root 50, you'd have to break that down to root 25 times root 2. That's the only option. The square root of 25 is 5, so the answer is 5 root 2. You've taken the square root of the 25, so that radical sign is gone. It did its job. The only radical sign that's left will be the 1 on the 2. So C is an example where you may not take out the largest common or perfect square. For example, you might say, well, I know that 4 times 12 is 48. So break it down to root 4 root 12, which is 2 root 12. But that one is not finished because 12 can be broken down further to root 4 root 3. The square root of 4 is 2 times the 2 in front gives you 4 root 3. So that is the final answer. But you could have got that right from the beginning by realizing that you could also go root 16 times root 3. 16 times 3 is 48. And the square root of 16 is 4. So this way you get it in one step instead of two. In the end, it doesn't matter as long as you get the answer. But if you look for the largest perfect square, that means you can do it in one step instead of two steps. All right, question D, root 72. So there's another one. There's a couple different perfect squares that you can use, but the largest one would be root 36. 36 times 2 is 72, and the square root of 36 is 6. So it's 6 root 2 as the final answer. Question E, root 45. Only one option there, and that would be root 9 root 5. Right? You need to find two numbers that multiply to get 45. One of them has to be a perfect square. So 3 root 5 is the final answer. And question F, the root of 500. Not as bad as it seems because 100 times 5 will give you 500. 100 is a perfect square. The square root of 100 is 10. So 10 root 5. And once again, you can always check these. The root of 500 is that decimal. We got 10 root 5, same decimal. So our answer is equal to what we started with. So make sure you're aware of the differences between a mixed radical and entire radicals and how you go between them. We talked about irrational numbers yesterday. Those are numbers that are non-repeating, non-terminating decimals. They cannot be expressed as a fraction. So 5/8 is not irrational, it's rational. It is a fraction, so it's rational. If you were to write that as a decimal, 5/8, it's a terminating decimal. A terminating decimal is rational. Same thing with a repeating decimal, 0.6 repeating. It actually comes by going 2 divided by 3. That's where that comes from. It can be expressed as a fraction. A repeating decimal can be written as a fraction, so that is a rational number. The next one is the square root of 0.25. So if we find out what that is, that's 0.5. So that is a rational number. It is a decimal that terminates. The last number is the cube root of 84. Cube root of 84 is a decimal. It doesn't terminate and it doesn't repeat. Your calculator has only so much room to fill in digits, and then it has to stop and it rounds off the last number. So there are more digits. The cube root of 0.84 is irrational. It's 4.4. So this is approximately 4.4. It is irrational. This one here was 0.5. 5/8 was 0.625. So if we arrange them from smallest to greatest, the smallest number here is our 0.5. So it's the root of 0.25. The next number would be 0.625, which is 5/8. The next number would be 0.6 repeating. And the last number, the largest number, would be the cube root of, oh, I'm sorry. Let me go back and check that again. It's 0.84, not 84. 0.84. It's actually 0.94. So so it is the largest. The cube root of 0.84 is 0.94. So it is the largest of those four numbers. But the only irrational one is the last one. Question B, 3 root 28. That is an irrational number because 28 is not a perfect square. So this is irrational. And again, its value is approximately 15.87. The square root of 225 is exactly 15. So it is rational. The next number, 15 and 4/5, that's 15.8. You go 4 divided by 5 on your calculator, and you'll get 0.8. It is a mixed number, so it can be written, it is a rational number. It is rational, not irrational. And the last one, the fourth root of 625. The fourth root of 625 is exactly 5. So it is rational, not irrational. There's only one irrational number here. And that is 3 root 28. So if we're going to arrange them from smallest to greatest, the smallest number is the fourth root of 625, which is 5. Then the next one is 15, the square root of 225. Then 15.8, that's 15 and 4/5. And then finally 15.87, or 3 root 28. Okay, so on to the next page, talking about the laws of exponents. You want to simplify these. When you're multiplying powers with the same base, you add the exponents and the base stays the same. So that's what you'll do. You'll add the exponents and the base stays the same. Now, 3 plus negative 5 is negative 2. But remember, we have to turn negative exponents into positives. Remember that this is 1 times 4 to the negative 2. The 1 stays on top. The 4 will move to the bottom. And when you make that switch, the exponent sign changes. So 1 over 4 squared is the answer with a positive exponent. You could square the 4 and get 16, but you don't need to. It just says write with positive exponents. Question B, you're dividing powers with the same base. The law says you subtract the exponents and the base stays the same. When you subtract the exponents, the minus becomes a plus positive. It's negative 4 plus 2, which is negative 2. And again, this is 1 times 3 to the negative 2. The 1 stays on top, the 3 moves to the bottom, and the sign on the exponent becomes positive 2. Question C, again, you're dividing powers with the same base. You subtract the exponents and the base stays the same. 3 take away 7 is negative 4. This is 1 times 12 to the negative 4, or 1 over 12 to the 4th. So there's your answer for part C. Part D. I would do this in 2 steps. First, inside the bracket, you're dividing powers with the same base. The law says you subtract the exponents and keep the base the same. Negative 1 take away 0 is negative 1. That's raised to the power 3. When you have one exponent raised to another, you multiply the exponents and keep the base the same. So that'll give us 8 to the negative 3, or 1 times 8 to the negative 3. The 1 stays on top, the 8 will move to the bottom, and the exponent sign will become positive. So there's question D. For question E, again, one exponent raised to another, you multiply the exponents, base stays the same. 4 times negative 2 is negative 8. This is 1 times 5 to the negative 8. The 1 stays on top. The 5 moves down to the bottom, and the exponent sign becomes positive. So there's the answer to part E. Part F. The bases inside the bracket are not the same. So you cannot combine those two inside the square brackets. So what you would do is you would go straight to raising the powers inside to the power 3 outside. The power on 3 is 2, but 2 times 3 is 6. Times the power on the 2 is negative 5, times 3 is negative 15. The 3 to the 6th will stay on top, the 2 will move to the bottom, and the sign will become positive 15. There's your answer. Nothing else can be done because the bases are not the same. Okay? Are you okay with that, Allie? Yeah? Question G. Again, the bases are not the same. So we're going to have to go to the next step, which would be to multiply the exponents. 5 to the 2 times negative 1 over 4 to the 2 times negative 1. And now in this case, they will both swap places. The 4 will go to the top, the 5 will go to the bottom. And when you do that, those exponents change from negative to positive. Question H. You've got a base of 3.2 to the power negative 2, and that's all raised to the negative 3. Multiply the exponents. Negative 2 times negative 3 is positive 6. Base stays the same. And we have a positive exponent, so there's nothing else that we have to do. Question I. Inside the big square brackets, we have powers with the same base. So we can add the exponents. You're multiplying powers with the same base. you add the exponents. Negative 1 plus negative 2 is negative 3, raised to the power negative 1 outside. And now, because you have one exponent raised to another, you multiply the exponents. Negative 3 times negative 1 is positive 3. So there's our answer with positive exponent. Okay? Number 5, same types of questions. Simplify by restating it using positive exponents only. So for question A, the only one that has to move is the t. It's on the bottom with a negative exponent. It moves to the top. The s would stay on the bottom. Now you could keep that 1 there on top. It doesn't change anything. 1 times t to the 6 is just t to the 6th. Question B. Inside the square brackets, you're multiplying powers with the same base. The law says you add the exponents and the base stays the same. 7 plus negative 2 is positive 5. Now you have one exponent raised to another, so you multiply the exponents. This is 1h to the negative 10. The 1 would stay on top. The h would go to the bottom. So 1 over h to the 10th would be the answer. Question C. You've got the 8 on top, and you're dividing t to the 1 by t to the negative 3. Subtract the exponents. You'll get 1 minus negative 3. The minus minus becomes a plus positive, so 1 plus 3 is 4. The answer is 8t to the 4th. Question D, you have to cube everything inside the bracket, including the 2. And when you have x to the negative 4 cubed, you multiply the exponents, get x to the negative 12. The 2 cubed will stay on top, and 2 cubed is 8. That means 2 times 2 times 2. The x has to move to the bottom to make the exponent positive. So there's your answer. Question E, dividing powers with the same base, you subtract the exponents, the base stays the same. So it's 4 minus negative 4. The minus minus becomes a plus positive. So that'll be n to the 4 plus 4, which is n to the 8 to the negative 3. That'll be 1n to the negative 24, because you have to multiply the 8 and negative 3. The 1 stays on top, the n moves to the bottom. So it's 1 over n to the 24. For question F, everything inside the first bracket is raised to the power negative 3. The x is raised to the negative 3, and the y to the 4th is raised to the negative 3. So you multiply those exponents. And you have to multiply the exponents one last time, which will turn them both to positive values. So you don't have to move any of them. These next ones are all done the same. I'm going to go on to the next page and do a few from here, where the exponents are rational numbers. So for question A, you add the exponents. It'll be 3 over 1 plus 7 over 3. To add fractions, you need a common denominator. Our common denominator will be 3. So for the first fraction, you have to multiply top and bottom by 3. You'll get 9 over 3 plus 7 over 3. And now that we have our common denominator, we can add the top numbers, keep the same denominator. There's the answer. X to the 16/3 is the final answer. For question B, they both have the same base, so you add the exponents, and in this case, the two exponents already have a common denominator. So we don't have to find one, there's already one there. We add the top numbers, we'll get b to the 10 over 5, and 10 divided by 5 is 2. So that becomes b squared. Question C, you're multiplying the exponents. That's what you do when you have one exponent raised to another. So it's a to the 2 over 1 times 3 over 2. When you multiply those, you will get 6 over 2 because it's top times top, bottom times bottom. And 6 divided by 2 is 3. So there's the final simplified answer. Question D, multiplying powers with the same base, you add the exponents. So you're going to add 4.8 and 3, which is 7.8. There's your final answer. Now, the instructions do say, where possible, compute numerical values. 16 to the power 0.25. That's the same thing as 16 to the power 1/4. And when you have a rational exponent, you can write it as a radical. The denominator, which is 4, tells you what root it is. That's the 4th root of 16. The top number of the fraction is 1, tells you what power it's raised to. So that's the 4th root of 16, which is 2 to the power 1, which is still 2. You can get that on your calculator. The 4th root of 16 is asking what number times itself 4 times is 16. 2 times itself 4 times gives you 16. Right? Question F. Everything inside the brackets raised to the power 1/3 outside. And power 1/3 means the cube root. So you're going to have the cube root of negative 8a to the 6 over the cube root of 27. The cube root of negative 8 is negative 2. Negative 2 times negative 2 times negative 2 does give you negative 8. And the cube root of a to the 6 is a squared. When you multiply a squared by itself 3 times, you will get a to the 6th. And on the bottom, the cube root of 27 is 3. So there's the answer. Question G. Multiply the coefficients together. 2 times negative 4 is negative 8. And then when you multiply the x's together, you have to add the exponents and keep the base the same. So this will give us negative 8x to the 6/3, and 6/3 is 2. So there's the answer for H, or for G, excuse me. For question H, everything inside the bracket is raised to the power 3/2. The 9 is raised to the 3/2, and the x squared is raised to the power 3/2. When you raise 9 to the 3/2, that's the square root of 9 cubed. The denominator tells you what root it is, the top number what power it's raised to. For the x, you're going to multiply the exponents. It'll be 2 over 1 times 3 over 2. The square root of 9 is 3, and 3 cubed is 27. When you multiply 2/3 by 2 by 3/2, I should say, 2 times 3 is 6, over 1 times 2 is 2, 6 divided by 2 is 3. Another way of looking at that is that the 2's cancel, and you get 3 over 1. Question I, everything inside the brackets raised to the power 0.5, which is 1/2. And power 1/2 means square root. 25 to the 1/2 is the root of 25. When you multiply the exponents, 2 times 1/2 is 1, so it's x to the 1 or x. The square root of 25 is 5, so that becomes just 5x. Okay, I'm going to go on to the next page and the next page after that. Let's do some questions where we are multiplying polynomials. We did these using the distributive property. We took the x and the x plus 5 and multiplied it by x minus 2, and then the positive 5 from the x plus 5, also multiply that by x minus 2. When you multiply them out, then collect the like terms. Like terms are terms that have the same variable to the same exponent. Negative 2x to the 1 and 5x to the 1 are like terms. You can combine them. Negative 2 plus 5 is positive 3 of those same things. So there's your final simplified answer. X minus 3 squared. Well, squaring something means multiplying it by itself. If you just say it's x squared plus 9, you're wrong. There's more to it than that. So you use distributive property. Okay, Brooklyn? Multiply it out. So it actually does have an x squared, and it does have a plus 9, but there's also one more term. Negative 3x, take away another 3x is negative 6x. There's the final answer when you multiply out those binomials. Question C. Again, using distributive property. You're going to get c squared plus c times d. Now this next one will be negative d times c or negative cd. Doesn't matter what order they're in. And then minus d squared. In this case, the cd's cancel. Positive cd, take away cd, they cancel. You'll get c squared minus d squared. There's the final answer to that one. I'm going to skip to question F. Again, we'll use distributive property. The 4j's multiplied by both terms in that second binomial, and then the positive 2k is as well. So that'll give us 24j squared negative 12jk plus 12kj, which is the same as jk, minus 6k squared. And once again, negative 12jk plus 12jk, they cancel. You're left with 24j squared minus 6k squared. There's the final answer. So we're going to use the distributive property for the questions in number 4 as well. So for question A, you just got x in front multiplied by all three terms inside. Remember, when you multiply powers with the same base, you add the exponents. So this will give us 3x cubed minus 5x squared plus 8x. You're done in one step. From there, I'm going to skip to question C. It's a binomial times a trinomial. So I'm going to take the x from the binomial multiplied by all three terms in the trinomial. Then I'll take the minus 3 from the binomial, and again, multiply by all three terms in the trinomial. That's what distributive property tells us to do. So when I multiply, I'll get 6x cubed minus 4x squared minus 12x minus 18x squared plus 12x plus 36. And so now it's just a matter of putting my like terms together. I've got two terms that are x squareds. Negative 4x squared, take away 18x squareds would be minus 22x squareds. Negative 12x plus 12x cancel. You get 0x's, which is 0, and then you have the plus 36 on the end. So there's the answer to part C. D is done the same way. So multiplying out, when you multiply everything in the second bracket by -1, the signs just change. And then we'll put our like terms together. 8x squared minus 5x squared will give us positive 3x squared. Negative 10x, take away 4x is negative 14x. And so there's our final answer. Let's skip to question F. So you got a trinomial times a trinomial. So I'll start with the 2y squared. It's all going to be multiplied by all three terms in that trinomial. So this is question F. So the 2y squared will be multiplied by all three terms. Then the second term, the positive 3y's multiplied by all three terms. And then finally the -1 multiplied by all three terms. So that'll give us 2y to the fourth plus 8y cubed plus 10y squared. Multiplying out the next ones, we'll get positive 3y cubed plus 12y squared plus 15y. And then for the last one, multiplying them all by -1 just changes the signs. So I've got 2y to the fourth. 8y cubed plus 3 more y cubes gives us 11y cubes. In this case, it might be helpful to cross out the terms as you deal with them so you don't miss any. 10y squared plus 12y squared is 22y squared, but then we have a -1. That'll give us positive 21y squareds. So I dealt with the 10y squareds, 12y squared gives us 22, -1 is our 21y squareds. And then we'll have 15y take away 4y, which is positive 11y, and then the -5. So there's the final simplified answer after multiplying all those out. Okay? So these next ones are similar, except not only are we multiplying, but we're also then simplifying after. Let's look at starting with question B first. So I'll take the f in the f plus 7 and multiply by the 2f minus 4. Then the positive 7 is also multiplied by 2f minus 4. And then I have to subtract what you get when you multiply 3f plus 1 by itself. And notice I've used those big square brackets because order of operations say we multiply first before we subtract. So I'm going to get 2f squared minus 4f plus 14f minus 28. And now I'm going to use the distributive property here. So negative 4f plus 14f is positive 10f. Minus. When I multiply these out, I'll have 9f squared plus 3f plus another 3f plus 1. And now, when I collect my like terms here, I'll get plus 6f plus 1. And a negative sign in front of the bracket changes all the signs inside that bracket. So the 9f squared will become negative, the 6f will be negative, and the 1 will be negative. This will give us negative 7x squared plus 4f minus 29. There's your final simplified answer for that one. Okay, negative 7f squared. I know I kind of maybe took it over a bit too far to the left to see it. There we go. Okay, so that was question B. Let's do question C, but I'm going to copy it to a new page here. Yep. So what's different here? There's a plus sign between the brackets, so you don't have to worry about changing any signs. But we have to use a distributive property to multiply them out. And this distributive property for the second set. So multiplying them out, this will be 3bd minus 10bd plus 6d squared. That'll be 4b squared plus 1bd plus 4bd plus 1d squared. So the 5b squared and the 4b squared can be added together to get 9b squared. So again, I've taken care of these two terms. Negative 3bd, take away 10bd is negative 13bd. Plus 1 will be negative 12. Plus 4 will be negative 8bd. So again, I've dealt with all the bd terms. So all we have left to do now is add 6d squared plus 1 more gives us plus 7d squareds. And there is the answer to that one. That was question C from that previous page. All right. We'll start looking at factoring. The first thing you always look for is a common factor. In question A, there is a common factor of 5 there. All the terms are divisible by 5. That's the largest number that divides into both terms. So that's your first factor. The second factor goes inside a bracket, and to get the second factor, you divide each of the terms by the common factor. 5x divided by 5 is just x. Positive 15 divided by 5 is positive 3. There's your factors. Factors are things that multiply together to get what you start with. Question B, the common factor there is just the letter y. And when you divide each term by y, you'll get 3y take away 5. There's your factors. Question C. The common factor there is the letter w, but it'll be w squared. Each of those terms has a w squared in it. To get the other factor, you divide each term by w squared. There's your factors. Common factor. Question D. The common factor there is 6ab. When you have terms, when you have the same variable in all the terms, the smallest power will be the common factor for that variable. To get what's left, to get the other factor, you divide each term by the common factor. So the first term, when you divide the 6's, they cancel. A cubed divided by a is just a squared. When you divide the b's, they cancel. Minus 18 divided by 6 is 3. When you divide the a's, they cancel. B squared divided by b is b. There's your factors. Common factor of 6ab. Your other factor is a squared minus 3b. Question E. There's a common factor there of 3x. To get the other factor, divide each term by 3x. That'll give you 3x squared minus 4x plus 2. And that one cannot be factored any further. These next ones, if we look at question A, there are two terms there. There's the first term. There's the second term. They both have a y minus 2. That is your common factor. To get what's left, divide each term by y minus 2, and they'll cancel. You're left with 3y plus 4. There's the factors for A. B is set up the same way. There are two terms there. Both of those terms have an a minus 4. That is our common factor. To get what's left, divide each term by a minus 4. We'll get 5a minus 2. And there's the factors. For question C, we need to group them together first. And the way we did it is we usually group the first two terms together and the last two, and we made sure that there was a plus sign in between the brackets. And then we took out a common factor in each group. In this first group, there is a common factor of 2x. And if you take it out, you'll be left with c minus 4. The common factor in the second group is positive 7. Take it out, you're also left with c minus 4. Now it becomes just like questions A and B. There are two terms. Both terms have a c minus 4. That's your common factor. You're left with 2x plus 7. There's the answer to question C. For question D, same thing. Except remember, we always want to group them together so there's a plus sign in between the brackets. So I'm going to put a plus in there, and then I'll write my negative 8x plus 24. If I remove the plus, if I remove the brackets, nothing changes. A plus sign in front of a bracket changes nothing. There is a common factor in this first group of 3x. Take it out, you'll get x minus 3. The common factor we take out of the second group needs to be negative 8 because we need to get the same thing inside this bracket as we have here. And if you take out a common factor of negative 8, you will also get x minus 3. So now you've got two terms. They both have an x minus 3 in it. That's your common factor. Take that out, you're left with 3x minus 8. There's the factors for question D. Yep. For question E, we'll do it the same way. We'll group the first two terms together, and I'll put a plus sign and then put the last two terms together with the negative signs in front like they are in the question. There is a common factor in this first group of y cubed. Take it out, you'll get 2y plus 1. And if we take out a negative 5 out of the second group, we'll also get 2y plus 1. So now I've got two terms. Both terms have a 2y plus 1. That's our common factor. Take it out, you'll get y cubed minus 5. There's the final factors for that. Number 4. Remember, when you're factoring, you're trying to find things that multiply together to get what you start with. In most cases, if you have a trinomial with no common factor, your factors will be binomial factors. The front terms multiply to get x squared, so that'll be x and x. The last two terms have to multiply to get 10 and add to get 7. Two numbers that work there will be positive 2 and positive 5. They multiply to get 10, add to get 7. There's your factors, and you can always check by multiplying. See if you can do the next one. Where are you going? We already went, got a drink already. Yeah, yeah, you can. Question B. The front two terms have to multiply to get j squared, which will be j and j. And now you're looking for two numbers that multiply to get plus 27, add together to get plus 12. Positive 9 and positive 3 are the factors. And remember, you can always check by multiplying. Whoops. Using distributive property. That'll give you j squared plus 3j plus 9j plus 27. The 3j and the 9j add together to get 12j. That's what you started with. So it works. You can always check these. For question C, the front terms multiply to get k squared, and we need two numbers that multiply to get 4, add to get 5. Positive 1 and positive 4 work. Those are the factors. Question D, multiply to get p squared, p and p, and two numbers that multiply to get 12, add to get 9. Well, 6 times 2 will not add to get 9. 4 times 3 will not add to get 9. 1 times 12 will not add to get 9. In this case, there are no factors. But on the final exam, if you're asked to factor a polynomial, there will be factors. You will not get any that can't be done on the exam. Question E, front terms multiply to get d squared. And now we want two numbers that multiply to get 24, add to get 10. Positive 4 and positive 6 will work. Question F, doesn't matter that there's c squared and d squared. All that'll be different is you'll have a c in the first bracket and d's in the second bracket. But the rest is done the same way. Two numbers that multiply to get positive 21, add to get positive 4. Well, in this case here, there are none that'll work for that part. 7 times 3 is 21, and 7 minus 3 is 4, but their signs have to be the same to get a positive 21d squared at the end. But once again, on the final exam, there will not be any questions where there are no factors. If it asks you to factor, that'll be factorable. Okay, we're going to stop there for today. We'll pick this up again tomorrow. I'm going to hand out a